Many technologies have been inspired by nature. In this video, we are going to cover 1. When and how the concept of airplane initiated. 2nd, evolution of airplane over centuries. 3rd, airplane during war. And 4th, the present airplane. Families, welcome to my YouTube channel.
The history of the airplane spans more than a century of innovation, experimentation, and achievement. It begins with ancient dreams of flight and culminates in today's sophisticated air travel and aerospace technology. The dream and concept of flying is as old as mankind itself. Men and women tried to navigate the air by replicating the birds. They built wings to strap onto their arm or machines with flapping wings called ornithopter. One of the earliest known designs for an ornithopter was sketched by Leonardo da Vinci in the late 15th century. An ornithopter is a type of aircraft that flies by mimicking the flapping motion of birds' wings. The name comes from the Greek words ornis bird and pteron wing, meaning bird wing. Unlike conventional airplanes that rely on fixed wings or rotary wings for helicopter and engines for propulsion, an ornithopter attempts to achieve flight by flapping its wings up and down or in a similar motion to how birds, insects, or bats fly. Key features of ornithopters is flapping wings. The defining feature is that the wings move to create both lift and thrust, unlike traditional aircraft where lift comes from fixed wings and thrust from engines. The trouble is, it works better at bird scale than it does at the much larger scale needed to lift both a man and a machine off the ground. Montgolfier hot air balloon. The Montgolfier hot air balloon was the first successful human-carrying flight technology and marks the beginning of human aviation. It was invented by two French brothers, Joseph Michel Montgolfier and Jacques-Étienne Montgolfier, in the late 18th century. The Montgolfier balloon demonstrated that humans could achieve flight using heated air as a means of lift. In 1783, the Montgolfier brothers, who came from a paper manufacturing family, became fascinated by the idea of flight. They discovered that hot air rises when they observed embers lifting into the air from a fire. Their idea was to create a large balloon made of lightweight materials, which could be filled with hot air to lift the balloon off the ground. How it worked. The Montgolfier balloon operated on the principle that hot air rises because it is less dense than cold air. Here we can mention the relation between oil and water. Oil is lighter than water. It floats over water because its density is lower than that of water. The molecules that make up the oil are larger than those that make up water, so they cannot pack as tightly together as the water molecules can. They take up more space per unit area and are less dense. The fire under the balloon heated the air inside the fabric, causing the balloon to ascend. When the air cooled, or when the fire was reduced, the balloon would descend. On June 4, 1783, the brothers launched an unmanned balloon in Annonay, France. On September 19, 1783, the Montgolfier brothers conducted a flight with living passengers, a sheep, a duck, and a rooster. The Montgolfier brothers' invention was revolutionary, as it demonstrated for the first time that humans could leave the ground and fly. Sir George Cayley, 1773 to 1857, is often regarded as the father of aviation, because of his pioneering work in aerodynamics and aircraft design. He made significant contributions to the understanding of flight and laid the groundwork for the development of modern airplanes. His work during the early 19th century established key principles of flight that later inventors and engineers, including the Wright brothers, would build upon. In 1799, Sir George Cayley was the first to identify the 4 fundamental forces that act on an aircraft and presented the first scientific design for a fixed-wing aircraft. Building on his pioneering work in aeronautics, scientists and engineers began designing and testing airplanes.
4 forces of flight are lift, drag, thrust, weight.
Lift, the upward force that counteracts gravity, allowing the aircraft to rise. Drag, the resistance or backward force that opposes the aircraft's motion through the air. Thrust, the forward force that propels the aircraft through the air, typically provided by engines in modern aircraft. Weight, the downward force due to gravity acting on the aircraft's mass.
Followers.
What force makes an airplane fly? Put the answer below. Unlike earlier attempts at flight, which often focused on flapping wings like a bird, as in the ornithopter, Cayley recognized that fixed wings could provide lift if designed correctly. He proposed separating the lifting surface, wings, from the propulsion system, laying the foundation for modern airplanes. He suggested that wings should be curved to create lift more efficiently. This concept of cambered wings is now a fundamental aspect of modern aircraft design. In 1804, Cayley built what is considered the first successful glider, a model with a fixed wing, tailplane, and rudder. His design was a major step forward in understanding how to achieve controlled flight. Sir George Cayley's aircraft were primarily gliders, meaning they were unpowered and relied on gravity and air currents to generate motion. Cayley's most significant contributions involved understanding the principles of aerodynamics and the design of fixed-wing aircraft, but at the time, there was no effective power source available to provide the thrust needed for sustained flight. Cayley's models and full-size gliders were not powered by engines. Instead, they were launched from elevated positions, allowing them to glide downward using the principles of lift generated by their wings. Finally, Cayley built a larger glider capable of carrying a human, the glider being launched down a hill to take advantage of gravity and air currents. After Cayley's glider experiments, the next major figures in aviation focused on solving the problem of powered flight. This development came later in the 19th and early 20th centuries when new lightweight engines became available. A German aviation pioneer, Otto Lilienthal, built and flew many gliders in the 1890s, providing valuable data on wing shape, lift, and control. However, like Cayley, his work was focused on unpowered gliders, though his designs were more advanced. Samuel Langley, 1896. American scientist Samuel Langley built powered flying models with small steam engines, achieving short, unmanned flights. His later manned attempts, however, failed due to instability. Next we will discuss about Wilbur and Orville Wright, the most famous pilots in the history of flight. The Wright brothers, Orville and Wilbur, were the first to achieve a heavier-than-air, controlled, powered and sustained flight on December 17, 1903, in Kitty Hawk, North Carolina. And they flew for 12 seconds, covering 120 feet. Their aircraft, the Wright Flyer, 1903, used a gasoline-powered internal combustion engine, which provided the necessary thrust to keep the aircraft airborne. The Wright brothers succeeded because they built upon Cayley's principles of aerodynamics, fixed wings for lift and separate controls for yaw, pitch and roll, and added a lightweight engine that provided consistent propulsion. The Wright Flyer's engine was custom-built and was lightweight enough for flight, which was a critical advancement over earlier heavy steam engines. Following Cayley, other inventors like Clement Ader and Otto Lilienthal made incremental advances, but they couldn't fly successfully until the Wright brothers in 1903 that powered, controlled flight was achieved. They used a lightweight gasoline engine, marking the true birth of powered aviation. The Wright brothers' 1903 flight was the beginning of the era of powered, controlled flight, and their work laid the foundation for all modern aviation. Their methods for controlling an aircraft, particularly their three-axis control system, are still used in today's airplanes. After the Wright brothers' success, aviation began to grow, with inventors across Europe and the US improving designs. Aircraft still had limited range, speed, and reliability. World War I and World War II. The invention and evolution of the airplane during World War I and World War II played a pivotal role in the development of aviation technology. World War I, 1914 to 1918, aircraft were used for reconnaissance and later as fighters and bombers, significantly advancing aviation technology. Planes like the Sopwith Camel and Fokker Doctor I became iconic. Faster and more reliable planes were built during interwar period, transitioning from biplanes to sleek, metal monoplanes. Soon after, it became clear that reconnaissance aircraft needed protection from enemy planes, leading to the development of fighter planes. Some of the planes used in World War I. 1. Fokker Eindecker, Germany, the first plane with synchronized machine guns. 2. Sopwith Camel, Britain, one of the most famous World War I fighters, known for its agility in dogfights. 3. Spad S.13, France, a highly successful French fighter plane. 4. Handley Page O/400, Britain, a heavy bomber used for long-range bombing. By the end of World War I, aircraft had become a crucial element of military strategy. Controlling the skies, air superiority, became vital for successful ground offensives, as planes provided critical intelligence, disrupted enemy communications, and attacked ground forces. World War II. By the time World War II began, airplanes had evolved significantly, with advancements in speed, range, maneuverability, and weaponry. Airplanes became central to military strategy in both the European and Pacific theaters. Key roles included fighter planes, bombers, transport aircraft, and specialized planes like dive bombers and torpedo bombers. World War II saw the extensive use of strategic bombers, which were capable of carrying large payloads of bombs to destroy enemy infrastructure, factories, and cities. The American B-17 Flying Fortress and B-24 Liberator were long-range bombers used in large-scale bombing campaigns over Europe, such as the bombing of Dresden and the Battle of the Ruhr. The British Avro Lancaster and the German Heinkel He-111 were also major bombers. The American B-29 Superfortress was used in the Pacific, most famously to drop the atomic bombs on Hiroshima and Nagasaki in 1945. During this period, radar was an essential technological advancement, allowing aircraft to detect enemy planes and ships from greater distances and in poor visibility conditions. By the end of World War II, jet aircraft had been developed, providing a glimpse of the future of aviation. The German Messerschmitt Me-262 was the world's first operational jet-powered fighter, and it could outpace any Allied aircraft. Technological advancements like radar, jet engines, and long-range bombers transformed military aviation into a dominant force. The developments in aviation during these two world wars laid the foundation for modern military and civilian aviation. 1945, 1950s, the jet age begins. Introduction of jet engines. The end of World War II saw the emergence of jet engines, which had been in development during the war. The first operational jet-powered aircraft, the German Messerschmitt Me-262, had proven the potential of jet propulsion. After World War II, both military and civilian aircraft quickly adopted jet engines due to their
higher speed,
altitude capabilities, and greater efficiency over piston engines. The British de Havilland Comet, 1949, became the world's first commercial jet airliner. Although early versions had structural flaws, the Comet laid the groundwork for the future of commercial jet travel. Military jets. During the late 1940s and 1950s, military aviation transitioned fully into the jet age. The Cold War between the United States and the Soviet Union pushed the development of faster and more powerful fighter jets and bombers. Key military jets included the F-86 Sabre and MiG-15, which faced off during the Korean War, 1950 to 1953. These aircraft were among the first to engage in large-scale jet dogfights.
Supersonic flight.
In 1947, Chuck Yeager became the first person to break the sound barrier, Mach number equals 1, in the Bell X-1 rocket-powered aircraft. This achievement paved the way for the development of supersonic aircraft. Supersonic military jets, such as the F-100 Super Sabre, USA, and MiG-21, Soviet Union, were developed during the 1950s and 1960s, offering exceptional speed and maneuverability. From 1960 to 1970, commercial aviation takes off and space exploration. In the 1960s, the commercial aviation industry saw the rise of large long-range jet airliners that revolutionized air travel by making it faster, more affordable, and accessible to the public. The Boeing 707, first flight in 1957, introduced in 1958, was one of the most successful early jetliners, opening up intercontinental and long-haul flights. This aircraft marked the start of the jet age in commercial aviation. Boeing 747 and the jumbo jet era. The introduction of the Boeing 747 in 1970 marked the beginning of the jumbo jet era. The term jumbo jet usually refers to the largest variants of wide-body airliners. Examples include the Boeing 747, the first wide-body and original jumbo jet. Airbus A380, super jumbo jet. Boeing 777X and Boeing 777, mini jumbo jet. The 747 could carry more than 400 passengers and was designed to meet the growing demand for air travel. This large-capacity aircraft became an icon of international air travel, helping airlines to reduce costs per passenger and making long-distance travel more economical. Supersonic passenger flight. The Concorde, developed jointly by the UK and France, made its first flight in 1969 and entered commercial service in 1976. It could fly at Mach 2, twice the speed of sound, and drastically reduced intercontinental flight times. Although the Concorde was a technological marvel, it was expensive to operate and had a limited market due to its high costs, noise, and limited range. It remained in service until 2003. Space exploration and rocket technology. The post-World War II period also saw a shift towards space exploration, with airplanes playing a significant role in high-speed flight research. This eventually led to the development of the space race between the US and the Soviet Union. NASA's X series of experimental aircraft, such as the X-15, tested the boundaries of speed and altitude, providing critical data for space exploration. In 1969, the Apollo 11 mission landed humans on the Moon, but airplanes continued to serve vital roles in transporting astronauts and testing spacecraft designs. 1980 to 1990, technological advancements and new designs. Fly-by-wire and digital technology. The 1980s and 1990s saw major advances in avionics, aviation electronics, including the widespread adoption of fly-by-wire systems. These replaced mechanical control systems with electronic ones, making planes more reliable, responsive, and easier to fly. The Airbus A320, introduced in 1988, was the first airliner to feature a fully fly-by-wire system, setting a new standard for future aircraft. The A320 became highly successful and led to the rise of Airbus as a major competitor to Boeing. From 2000 to present, the modern aviation era. In the 21st century, there has been an increasing focus on fuel efficiency and reducing the environmental impact of aviation. Newer aircraft designs prioritize lightweight materials, such as composites, aerodynamic improvements, and more fuel-efficient engines. The Boeing 787 Dreamliner, first flight in 2009, and the Airbus A350, first flight in 2013, are notable examples. Both planes use composite materials for a lighter structure and are equipped with advanced engines that significantly reduce fuel consumption and emissions. The Airbus A380, introduced in 2007, is the world's largest passenger airliner, capable of carrying over 850 passengers in an all-economy configuration. It was designed to serve high-density routes between major international hubs. Fifth-generation fighter jets like the F-22 Raptor and F-35 Lightning II have become the most advanced aircraft in military aviation, featuring stealth capabilities, advanced avionics, and powerful weaponry. Unmanned aerial vehicles, UAVs, or drones, have also become prominent in military operations, offering capabilities for reconnaissance, surveillance, and combat without risking human pilots. Recent developments have focused on electric aircraft and the potential for autonomous flight. Companies like Joby Aviation and Vertical Aerospace are developing electric vertical takeoff and landing (eVTOL) aircraft, which could revolutionize urban air mobility. Autonomous systems are also being tested for future airliners, potentially reducing the need for human pilots in certain operations. Space exploration has entered a new era of commercial spaceflight with companies like SpaceX, Blue Origin, and Virgin Galactic developing reusable rockets and spacecraft to transport passengers to space. 2000s present fuel-efficient designs, the rise of low-cost airlines, advancements in drones and autonomous flight, and the development of electric aircraft have shaped the modern. So, as we have seen from the video, the airplane has transformed from simple wooden fabric structures to advanced machines capable of flying at supersonic speeds and exploring space, reflecting the immense technological progress made over the past century.
Please subscribe, like, share. Thank you.